Hello, this is Professor Gibson. This is a video on section 11.5 in Math 115. The topic of this section is measures of position. All right. So position being, where in a data set is it? Is it in the middle? Is it close to the bottom? Is it close to the top? Is it a third of the way up from the bottom? What are we talking about? Where you're talking about an individual data value? Well, where is it? All right. So we have some terminology to start with. Percentile, sometimes called percentile rank, of a data value indicates the percent of data values in a data set that are below that particular data value. For example, a test score in the 73rd percentile, right? So if it says 73rd percentile, is higher than, right, 73% of the scores. Okay, that's the definition. Let's talk about an example for ways these are used. Percentiles are used very commonly in healthcare, especially pediatrics. To monitor a child's development, doctors compare the child's height, weight, and head size at a certain age to measurements of other children at the same age. If a child's percentile suddenly changed radically, the doctor might suspect a problem in the child's development. So see, the difficulty in tracking things with children is that all their details are changing, right? Their height changes, their head size changes, their weight changes. So you can't really, it's getting bigger or smaller. It's the best way to do it is to compare these changes sort of proportionally as the percentile, right? So a child most of whose weight is in the 70th percentile and whose height's in the 90th, if that suddenly changes, right, either one of those percentiles, then it means there's something you should look into. All right. So anytime you've got something, you're trying to track things that change, percentiles come into play, or at least can come into play. All right, small note here, why to use the method in the book. There's a few different methods for computing percentiles. It's possible you know one. We're just going to use the one I'm getting ready to show you here, both because it's relatively simple and it's pretty much, honestly, it's about as accurate as anything. It's stable. Okay. All right, so here's our formula. Percentile for a given percentile of a value of x, right here, percentile of a value of x. It's the number of data values less than x over n being the total number of data values times 100. Or I kind of shorthanded it here, number of values less than x over n, and then the times 100 just turns it into a percent. Okay, our book is percent. All right, question, we're going to do one. The number of words in each of the last 10 presidential inaugural addresses is listed below. Find the length that corresponds to the 30th percentile. Now, I worded this one this way to kind of highlight an issue here. So let's look at this. All right, there's 10 data values here. You count them up, there's 10. So the 30th percentile, well, 10 times 30% or 0.3 gives me 3, right? So the 30th percentile means that our data value, right, whatever it is going to be bigger than 3 of these 10, right? Because bigger than 30%. All right, well, if you look over here, I've sorted these in order. Usually in these questions, you have to sort them yourself, but on this example, I sorted them in order. Well, bigger than 3 is anywhere in there, right? That's a huge gap, right, from 1598 to 2071. So instead of wording them, so I want you to see that, all right? So instead of wording them this way, what they usually will say is find the percentile for, and they'll give you a particular number, like 1750. And then any number here that fell between the third and fourth of the 10 data values would be in the 30th percentile. Okay? All right. Now, doing something similar to the what we did with the medical example to start with, we can use percentiles to compare values in different data sets. Two students are competing for one remaining spot in a law school class. Miguel is ranked 51st in a class of 1700. Dustin is ranked 27th in a class of 540. Without doing any calculations, which student is ranked higher? My first thought is hard to say, but Dustin's 27th, which is definitely higher than 51st. But Miguel's class is a lot bigger. All right. So let's do this. Let's start this. So the first step looking at Miguel, is we take Miguel's class size, 1,700, and we subtract off his rank, 51st. This leaves us 1,649 people who are ranked below Miguel. All right? We've got to turn that into a percent. So 1,649, that's the number of people below Miguel, ranked below Miguel, times 1,700, and then times 100 to turn it into a percent. Turns out to be a perfect 97%. So that's the 97th percentile. All right. Well, Dustin is ranked 27th in a class of 540. 540 minus 27 is 513. So that's how many people are ranked below Dustin. So 513 over 540, again, times 100 to turn it into a percent. And this turns out to be 95% exactly. So that's the 95th percentile. Miguel's is a little higher. 97th percentile is a little higher than 95th, right? Even though, all right, so that's it. Now, that's percentiles. The next thing we're going to do is talk about quartiles, but first I'm going to do a little reminder about the median, because we're going to need to use the median to find the quartiles. How to find the median? Step 1, sort the data in new order, right? Step 2, if there are an odd number of values, median's the middle value. All right? Step 3, if there's an even number of values, the median is the average of the two middle values, right? We've done this recently, but it's easy to forget stuff. Okay, so now let's go on to the thing that we're going to do that's new this time is quartiles. Okay, so what quartiles do is they divide a data set into four parts, each with the same or approximately the same number of data values. So what they are, there's quartile 1, quartile 2, and quartile 3. There's 3 dividers. Split the data set up into 4 parts that are as close to as equal as possible. And by equal, we mean have the same number of, as close to the same number of data values in between them as possible. Okay? Here's what you do. Step 1. Find the median of the data set. This includes, remember, you got to sort the data. The median is Q2. Q2 is the median. All right. Step 2. Find the median of the numbers below the median, right? In other words, figure out which of the numbers are below the median, and then the median of those numbers is Q1. Step 3, find the median of the numbers above the median, right? So find the numbers above the median, and the median of just those numbers is Q3. You do that, you've got your Q1, Q2, and Q3, all three medians. All three quartiles. All right, so here's an example with some numbers so we can work through. The data below are the percentages of total electricity generated that comes from nuclear power for the nations with the 12 largest economies in the world. Listed by size of economy, find the quartiles and describe what they mean. All right, so they list them in order here. They're not in size order, right? So I've already done that so that we wouldn't have to take the time to do a listing down here. They're going down here. They're in size order. You count them up, there's 12 of them. Okay, so the first thing is to find the median, right? Well, 12 of them means that the median is going to be, it's an even number, so the median is going to be the average of the two middle numbers, right? 15.8 and 3.7. The average is 9.75. Okay, that's our Q2. And it's right here in the middle between these two numbers, right? All right. Now we need Q1. If we count the numbers below Q1, it includes 3.7, which we just used, right? There's 6 numbers here. So again, it's going to be the average of the two middle numbers. It's going to be between 0 and 2.4. You can compute the average of those. That's Q1. It turns out to be 1.2, right? And again, because there was an even number, it's right between those two. Last bit, bottom 6 numbers above Q1, including the 15.8 we used earlier. Okay, that leaves us these two here. This is our Q3 here, right in the middle. And this turns out to be the average of those two numbers is 17.9. Okay, so there's finding the quartiles. All right, the last thing is really just a type of graph where you show the quartiles. Okay, what you do is you go across, actually they're laid horizontally like this. If the left edge is the minimum value in the data set, okay? So you graph the minimum value, you graph the first quartile, you graph the second quartile, you put the third quartile all on a number line, and then you put the maximum value on the number line, okay? Now it's called a box and whisker plot, or sometimes just a box plot, because what you do then is where you've got the Q1 and the Q3 marked, you draw a box, okay? What that does, because remember Q1 and Q3, between Q1 and Q3, half the data is in there. And then you draw another line to show Q2. So a quarter of the data is in here, another quarter of it's in here. And then out here, then you draw the lines out. There's a line out to the max with a marker. That's a whisker. That's the upper whisker. And then we have a line out to the minimum. And our low marker, that's the other whisker. All right. That's how you do those. There's not a huge trick to it. So let me show you how to do this on the questions that are actually in Connect Math. All right. So I've got a set of numbers here that I made up to work with one of the questions in Connect Math. Okay, so here's the question. Actually, the way these generally work, they have this little thing at the top that just describes box and whisker plots and talks to you about how they work and stuff, okay? What's actually happening here is you've got these sliders and you just have to drag the sliders to match. It's kind of fussy. There's not really any other way to do it. So in this one, like our minimum was 128.4. So you got to grab the slider. Actually, it's already there because I was messing with this earlier, right? We should just slide it back and forth till you got it right on. You see up above it says 128.4. Then you've got the next one, really, and you just slide them around, right, till you got them. 167.2. They're kind of fussy. Take this one. I already slid this one. 175, right? Take that one. 181.4. There we go. And then slide the last one to match the whisker, which I also already did, right? So in a sense, there's not a mental trick to it. What there is you really got to get some good fine control sometimes on sliding these things with your mouse. Okay, that's it. Measures of position. We're dealing with percentiles, quartiles, and box and whisker plots. I hope you found that helpful.